Take a look at this car, bicycle and tractor. Can you see the different types of wheels they use? Why do they use different wheels? The truth is, wheels with different sizes and dimensions can mean a lot as to how well they function in different situations. Let's see how. First of all, the most basic characteristic of wheels would be their dimensions. Mainly these would be their diameter and their width. Now let us use a few simple experiments to see how the dimensions help with the functionality of the wheel. For the first experiment, we are going to take two wheels with different diameters. Now, let's allow each wheel to roll forward for 1 revolution, that is, each wheel only takes a 360 degrees turn. Observe what happens. It seems that the larger wheel has gone further than the smaller wheel, even though they've only made 1 rotation each. How can this be? Well, this is because the larger wheel has a larger circumference, as shown. The length of this circumference shows how much distance the wheel can cover in 1 revolution. So, if two wheels turn with the same speed, the larger wheel travels a further distance. Thus, bicycles have large wheels, allowing them to move faster, and using a lot less effort to cover larger distances. Now, let's move on to the next experiment. Let's see what happens when we put obstacles in front of the wheels. First, for the large wheel. No problem. How about a small wheel? Well, it cannot roll over it, and it should be pretty obvious why. The obstacle is too tall for it. At most, a wheel can only run through obstacles that have less than half of the wheel's diameter. If we draw a tangent to the wheel at the contact point of the wheel and obstacle, we will get vectors of different angles. The greater the angle is relative to the ground, the harder it is for the wheel to roll over the obstacle. Thus, it is easy for the big wheel to roll over the obstacle, but it's almost impossible for the small wheel to do so. Let's not forget about the width of the wheels. Now what can the width do? Well, observe the following. Let's see what happens when they both drive through the terrain. Now, go. As we can see, the narrow wheels easily get stuck in the shifting terrain while the wide wheels are able to stay leveled on the surface. This is because a narrow wheel exerts a lot of pressure on the surface, causing it to push itself down into the terrain. Wider wheels have larger surface areas, preventing the wheels from getting stuck. One good example of this are bulldozers, that use crawler tracks rather than wheels. Since they mostly operate on muddy terrains, the large surface area the tracks provide prevents the bulldozer from being stuck. Of course, there are other factors that affect the use of the wheels, such as the material used, the tire tracks and so on, but those are more advanced, and will only really have obvious effects on larger vehicles. For now, the width and diameter would be enough. Then again, the uses of wheels are still limited. And sometimes, walking or crawling mechanisms are still better in crossing terrains that are too rough. In this lesson, let's see how we can overcome the limitations of wheels by implementing the caterpillar locomotion using rero.